Let's take a look at writing an equation for a graph when the graph given is either a sine or a cosine function. So looking at this graph, we can see here that the horizontal units are each 1 pi and the vertical units are all 1. So to get us started here, let's try and identify what our amplitude is. Now the easiest way to do that, I think, would be to just kind of eyeball where your midline would be. So we can see here that the line that would divide this function into 2 halves would be the line y equals -2. From the midline, we can see that we have to go down 3 units to get to the minimum, or up 3 units to get to our maximum, either way you want to think about it. And that is going to be our amplitude. So we know our amplitude is equal to 3, which would imply that our leading coefficient A would either need to be positive or -3 depending on the situation. The other way to think about determining your amplitude would be just go the entire distance from maximum to the minimum, which in this case would be 6, and then just cut that in half. You'll get the same answer either way. Next up, let's take a look at calculating the period. The easiest way again to do that would be to go from peak to peak. So if we measure from this minimum to this minimum on the right, we can just measure the distance it would take to go from one minimum to the other. We can see here it would have taken 4 horizontal units to get from one minimum to the other, so that is 4 pi. So the period would be 4 pi. Since we know that the period is equal to 2 pi over b, we can kind of set up this equation here. 2 pi over b is equal to 4 pi. We can solve for b and see that b should be equal to 1/2. So we've got our a, we've got our b. Let's take a look at finding the vertical shift. We can see that from our old midline here of the x-axis, everything has been shifted down 2 units. So if we know our vertical shift is down 2 units, then we know that our k is going to be equal to -2. So again, we've got our a, we've got our b, and we've got our k. The only variable that might be left for us to find is h for the phase shift, and we may not even need that. So let's take a look at our graph here. Taking a look at when x equals 0, we can see that our graph currently takes on a maximum value. The function that also would take on a maximum value when x is 0 is cosine. So thinking about this as a graph that is a cosine function, we can see that we wouldn't need to worry about a phase shift because everything lines up where it's supposed to be. X is 0, our f of x is the maximum value that we're going to see. And everything else kind of follows suit from there. We go to intercept, minimum, intercept. If we were to continue out, it would go out to a maximum. So no phase shift needed here to make everything line up. Last thing we need to do now is just kind of plug in the variables that we found. So we know that if our b is 1/2, we'll have 1/2 x, which is the same thing as x over 2. Our phase shift, again, we don't have one, so we don't have to worry about doing a plus or a minus 0 here for our h. Just close up our parenthesis. Vertical shift down 2 gives us a -2 on the end. And the last thing we have to worry about is our amplitude. Now, our a, we said, is either positive or -3. Since cosine normally has a maximum when x is 0, which is what we see here on our graph also, we know there hasn't been a reflection. If there was, our first point would have been a minimum. So since there's been no reflection, we're going to take the positive a value for this particular graph. And all said and done, this is our final answer. Our f of x is equal to 3 times the cosine of x over 2 minus 2.